everyone, welcome to our first lesson revising P7. There is a fill in the gap sheet that goes alongside this. You obviously do not have to do it, but if you would like to, then it is there for your pleasure. So I'm just going to talk through the main types of energy, the equations that go alongside them, and converting from one type to another, basically. So here we go. We've got, 6 types of energy. And there are some equations. Not all of them have equations. Chemical potential, for example, does not have an equation. Thermal, however, can... if I write on this. Yes, it is. Sorry, energy equals mc delta T. Mass, specific heat capacity, change in temperature. Kinetic, energy is half mv squared. M being the mass, v being velocity. Gravitational potential energy, I'm not going to write E equals for each one. Mass, gravitational field strength, remember that's 10 on Earth, times height. Elastic potential, half kx squared, where k is the spring constant and x is the extension or compression of your spring. And nuclear, although I have to say I've never really seen a question in GCSE on this, half mc squared, where m is the mass converted and c is the speed of light. All of those energies are measured in joules. I know you know this already. Quick note, conservation of energy. Energy is never created or destroyed. It is only transferred between stores. If you get onto A level and you start looking at quantum, well, that's not 100% true, but, we're rolling with that for GCSE. Now, there are several ways that you can transfer between stores. Remember that these are our stores of energy. So if I want to transfer between them, I can either do it mechanically, as in I can use a force, electrically, using a current. I can do it by heating by particles, convection and conduction, and heating by radiation. Now, I would just say these ones, in the old GCSE, there was a lot of information about convection, conduction, and radiation. In the new GCSE, I say new, it's been going since 2015, but they've taken that out. So I think they've almost left the names in there as a nod to the old spec, but you don't see very many questions on convection, conduction and radiation. What you basically need to know is that radiation is when it gives out infrared, so any hot object will give out radiation. Heating by particles, convection are liquids and gases, and then conduction is solids, basically. So just think, is it solid, liquid or gas? Doesn't even matter really, even if it's not any of those, because you just write heating by particles. You don't even need to say convection or conduction. So hopefully that's fairly straightforward. But either way, you need to know that energy can be transferred between the stores, one of those 4 methods. Now there are 2 equations that you need to know. If energy is being transferred mechanically, you use the work done equation. Remember, work done is force times distance. Electrically, energy transferred, or work done doesn't really matter, it's power times time. Well, it's the same one again. There you go. Right, so how to analyse energy. Sometimes we'll have a situation that changes, and at the beginning of the situation, energy is in one store and then it is transferred to another store. And you need to be able to say what energy it started at, how it was transferred, and what it ends at. So choose 2 points in a process. Identify which stores have more or less energy in them at those points. Work out which type of transfer has transferred the energy between them. For example, a penguin going up a hill on a ski lift. Point 1, halfway up the lift. I chose that as random. I could have done at the bottom of the list, could have done at the top of the list. In an exam, chances are they will tell you the beginning and the end so that you know which points you're actually dealing with. So anyway, halfway up the lift, the energy stored, kinetic energy because the penguins are moving, and a little GPE because they're halfway up the hill, so they have already got some GPE. There's a mechanical transfer because distance is moved. You could, I suppose, justify an electrical transfer in the theory that this is an electric ski lift, unless there's someone perhaps cycling at the bottom making it move. So you could justify electrical, that would also be okay. And point 2, at the top of the hill, the energy stored is gravitational potential energy, and there will be no kinetic left because they have then stopped at the top of the hill. So there's your example. So, sorry, the formatting's gone a bit funny here, isn't it? Calculating the energy transfer. A cyclist of mass 60 kilograms is at the top of the hill of height 15 metres. She then freewheels down the hill. What speed does she reach? So the first thing you need to do is identify your energy stores. And I said here, gravitational potential to kinetic. Step 2, calculate your beginning energy. GPE is mass times gravity times height. The mass was 60 kilograms. Gravitational field strength is always 10 on Earth. The height was 15, therefore she had 9,000 joules. Step 3, transfer your energy. We know it goes into kinetic energy, so that means there is 9,000 joules of kinetic energy. And kinetic energy is half mv squared. So 9,000 equals half times 60 times v squared. Step 4, rearrange your equation. V squared is 2 times kinetic energy divided by mass, gives you 300, square root it to find the speed, which is 17.3 meters per second. All right, hopefully that was a bit of a crash course, reminding you of all of that. We'll have lots of practice questions, and I'll see everyone later. Thanks.